Today, we are going to be looking at comparing rates of change. We're going to be comparing those in the course of linear functions. Just a reminder that rate of change is slope, which is also rise over run, or change in y's over change in x's. Graphically, you would be looking at the change in the y-axis and then comparing it to the change in the x-axis. The first question asks us to look at these two graphs and identify which has a greater rate of change. On the left side, we have a red line, and on the right side, we have a purple line. Which has the greater rate of change? Well, to determine that, we will need to compare their slopes. So to find the slope of the line that is red on the left, we will need to find its rise over run. Remember, we always go from left to right. So starting at the point on the left, we would need to rise 3 boxes and then move right 8 boxes. So the rise is 3 and the run is 8. So 3/8 would be our slope. Looking at the purple line on the right, to get from the point on the left to the point on the right, we would need to rise 5 boxes and run 1. So our slope is 5 over 1, or just 5. Now we're comparing the slopes of 3/8 and 5. 5 is greater than 3/8, so the graph on the right, the purple line, has a greater rate of change. Now let's take a look at those same two graphs on the exact same coordinate plane. What do you notice about the line, the purple line, that had the greater rate of change? Hopefully, as you look at those two lines and begin to compare them, you would see that the purple line, which has the greater rate of change, is steeper. Steepness is an indication of slope. The steeper a line is, the greater its slope, and therefore the greater its rate of change. So if you are comparing two linear graphs on a coordinate plane, you need to look for the graph that is steeper than the other. What if we have two equations? How can we tell which has the greater rate of change? In this case, I have given you two equations that are each in slope-intercept form, y equals mx plus b. Remember that m is slope, and slope is another word for rate of change. So we're looking simply for that number that is paired with the x, or is the coefficient of the x. In the equation on the left, the number 4 is the coefficient for x and is therefore the slope. In the equation on the right, the number 9 is the coefficient for x and is therefore the slope. So we are comparing the slopes of 4 and 9. Since 9 is greater than 4, the equation y equals 9x plus 3 has a greater rate of change. Now let's look at these two equations. They are not in slope-intercept form. Which of these has a greater rate of change? Because they are in standard form, you will need to solve for y so you can determine the slopes. Remember, when solving for y, it is your goal to keep y where it is and move everything else away from the y. In the equation on the left, that means we would need to move the term negative 3x. To move it, we would use its inverse, positive 3x. We would add that to each side of the equation. Negative 3x plus 3x is 0 and therefore goes away. So we would now have 2y equals 6 plus 3x. Remember, 6 plus 3x are not like terms and they cannot be combined together. Y is still not quite alone. We still have the 2 in front of it, so we need to divide each side of the equation by 2. 2 divided by 2 is 1, and therefore we just have 1y. 6 divided by 2 is 3. 3x does not divide nicely by 2, so we simply leave 3 over 2 and keep it with the x. Since it is with the x as its coefficient, 3 over 2 is the slope of the line on the left. In the equation on the right, 8x minus 4y equals 16, we need to move the 8x so we can get the y term alone. So we will use its inverse and subtract 8x on each side. 8x minus 8x is 0, and therefore we would only have negative 4y left on the left side of the equation, and 16 minus 8x would now appear on the right. Y is still not alone. We need to divide each side by negative 4. Negative 4 divided by negative 4 is 1, so we just have 1y equals. 16 divided by negative 4 is negative 4, and negative 8x divided by negative 4 would become positive 2x. Since the number with the x is 2, the slope is 2. So we are comparing the slopes of 3 over 2 and 2. Since 2 is greater than 3 over 2, the equation on the right, 8x minus 4y equals 16, has a greater rate of change. What if we have tables of values? How do we find out which has a greater rate of change? Well, remember, slope is rise over run, which is the change in y values over the change in x's. On the next slide, I have given you two options to calculate the slope this way. One of them is to simply look at the y's and the x's and to see how they change. Well, let's look at the purple table on the left. Remember, you want to do y's over x's. So as you look at your y values from 12 to 18 and then again from 18 to 24, those are changing by 6. Our x values are changing from 2 to 4 to 6, which is changing by 2 each time. So the change in 6 over the change in 2 would be a 3, and therefore our rate of change would be 3. Now, if you don't like doing it that way, you can pick any 2 points and use the slope formula. So on the purple table, I have used the top 2 points, 212 and 418. And picking those points, we would then subtract 18 minus 12 and 4 minus 2 and get 6 over 2, which is 3. So the rate of change is 3. And I just noticed a typo, so we're going to fix that real quickly. Now looking at the table on the right-hand side, the red table of values, we can again look at the change in y's over the change in x's. Now because I chose to use the top and the bottom points when I was calculating the slope, I used the top and bottom points to also find my changes. So in the y column, from 6 to 10 is a change of 4. And from negative 1 to 1 is a change of 2. So 4 over 2, which would simplify to 2. If you're going to write those points out, then you would write them as ordered pairs, negative 1, 6 and 1, 10. And we would use our formula, subtracting the y's on top and the x's on bottom. That would give us 10 minus 6, which is 4. Sorry. And 1 minus negative 1, which would bam bam to 2. So the rate of change is 2. We're now comparing those slopes of 3 and 2. Since 3 is greater than 2, the table on the left, the purple table, has a greater rate of change. Now we're going to put all three of those together. We are going to be given a graph, an equation, and a table, and we'll need to select which one we believe has the greater rate of change. Before I go on to the answer, take a moment and figure out which one you think has the greatest rate of change. All right, from the graph, we would need to count rise over run. I've used the y-intercept and then another point that's on a nice corner. It looks like we would rise 5 and run 1. So the slope would be 5 over 1, which is just 5. Looking at the equation, it is in y equals mx plus b form. So the y-intercept is the negative 15. The slope will be the number that is with the x, which is 8. So it has a slope of 8. From the table, we would want to identify our change in y's over our change in x's. Our changes in y are happening by 6, and our changes in x's are happening by 2, so 6 over 2, which is 3. So we are comparing the slopes of 5, 8, and 3. The greatest of those is 8. So the equation has the greatest rate of change. In summary, to compare rates of change in any type of linear function, whether it's given to you in a graph, an equation, or a table, you are always going to be comparing the slopes. The greatest slope will have the greatest rate of change.